It's truly an honor to be here today. I'm Colombian, and I love a good cup of coffee. Fortunately, so do a lot of other people, and coffee is an important economic engine. Unfortunately, if climate change continues unabated, the expectation is that by the year 2050, we will lose more than 50% of our coffee-making ability. Colombia will lose more than 90% of its coffee growing ability. They tell us climate change is about the rise by 10 meters of water by the year 2100. But climate change is not about sea level rise. Climate change is about a fundamental change in our ecosystem, in our way of life, and it will all happen during our lifetimes. I will be 90 in 2050, and I intend to be around. Therefore, this problem is urgent. This problem is now. But how do we deal with it? The reality is not only our fuels, our power, but also our chemicals. Everything that we use today, from our children's toys to our yoga pants to the carpet in our houses, all comes from fossil carbon. And so in my mind, what we must do is we must think of carbon as a precious molecule, and we must ensure that we handle carbon optimally. So in my mind, we have to think of carbon this way. Power can already be made renewably. There's no reason to waste carbon on power. However, fuels and chemicals still require carbon. And in addition, we must learn to recycle carbon. We must learn to not let it go up in our air. So if you consider this as a case study, what you're looking at here is how we normally would treat an emission in an industrial site. The carbon monoxide would be combusted to carbon dioxide. A few lucky molecules will be captured by a tree or a plant and then converted to product. What I would say instead is that what we ought to do is prevent all of that carbon from going up into the air, capturing it, and converting it directly to products. That's exactly what we do. What we do is we take carbon monoxide from a flue, and we have a bacteria that instead of eating sugar, eats carbon monoxide. It takes that carbon monoxide and converts it to ethanol very, very effectively. Now, I know this sounds a little bit like science fiction, but it's not. What you're looking at here is a 100,000 gallon per year facility. It's a demonstration facility that we built in China. It is simply taking a carbon monoxide rich emission from the steel mill, putting it into our bioreactor where it is fermented and converted to ethanol. It works. And we have, in fact, between 3 different demonstration facilities, more than 40,000 hours on stream, showing that this technology is viable. And what we are doing now is with Shaogang in China and with ArcelorMittal in Belgium, we are converting their emissions into commercial plants. The one in China will make 15 million gallons of ethanol. The one in Belgium will produce 21 million gallons of ethanol. These are being constructed now, and I expect the first one to be operating next year. So what is the impact on carbon? What happens now? If you look at the emissions when you capture the carbon and recycle it to make ethanol, you can see a significant reduction in the carbon footprint. What does this mean in real terms? That means that the 20 million gallon a year facility in Ghent is the equivalent of taking 100,000 cars off the road. And it will have the emissions reduction such that it'll be like 80,000 cars. Stop and think about that. Every year we've taken 80,000 cars off the road. It's almost like an instant 80,000 electric vehicles. Pretty significant. If I could use every steel mill off gas in the world, it would be the equivalent of taking 10 million cars off the road every year. That's real impact. One of the things that I get even more excited about when we make ethanol and convert it into a fuel, of course, it is a one-time recycle. If I can take that ethanol, make ethylene, and make polyethylene, I am capturing and locking in that carbon in a durable good. It's almost like carbon capture and sequestration, but not in the ground, but in a useful good. And that, to me, is even more exciting. We're here in Norway. I'm very happy to say that thanks to Innovation Norway and Eramet, we will be doing a feasibility study to see whether we can utilize their waste gases effectively to make ethanol. And I'm very excited that we will be starting this analysis. The other reason we're here in Norway is because we have developed a route for taking carbon dioxide, combining it with hydrogen, and then converting that through our bacteria and algae all the way to omega-3s, basically fish food. The reason that's exciting in Norway is because here is one of the only places in the world where you can have renewable hydrogen. And of course, this scheme of capturing CO2 requires a renewable source of hydrogen. If you're just going to make the hydrogen from natural gas, it defeats the purpose. The other reason we're excited about trying this with our partners here in Norway is because this is such a great fishing industry here. And so the ability to take carbon dioxide and make fish food is something that I believe is best implemented in a place like Norway. But stop and think about that future just for a second. Imagine that now you're using carbon dioxide to make valuable fuels, to feed fish, etc. This is the way we change the world. So carbon recycling, something I want to always be thinking about, has, I believe, environmental, economic, and social benefits. I hope that with the Eramet study, we'll be able to show this as an opportunity here. I am a big believer in the circular economy. Mother Nature wastes nothing. If mankind is to live on this planet, we need to learn to waste nothing. And therefore, if you can imagine a steel mill making the wings of the plane, I want you to also imagine the gas being used to power that plane. I want you to imagine the gases being used to make the tires that go on that plane. To me, this is the future. We're working to cross the valley of death and commercialize. This is a very expensive process, and my hope is that the legislators will appreciate that all legislation must be technology neutral so that everybody can have an equal footing and be able to demonstrate their technology. We are perhaps the first, but there will be many others who will capture waste gases. I'll conclude with this. We conquered space in the last century. This century, we conquer carbon. How we source, utilize, and dispose of carbon will define our generations. I welcome you all to work with us to change the world. Thank you.